So this is the experiment number 5. We have two practicals. One is to determine the viscosity of the given oil sample at different temperatures. Here are samples. We have two samples we are taking. That is two oils, 2T oil, and this one is 15W40 oil. This is petrol engine oil. And second one is we are determining the flash point of the diesel. When we are coming to the viscosity, viscosity means it is a property of the fluid. It offers resistance to flow. So why it offers resistance to flow? Because of the cohesive force between the molecules of the fluid. So this viscosity study is also important. So the oil viscosity that should not change much with varying the temperature. It should change within a range, because operating temperature range may be more, but it should be should not vary much. It should be in the suitable range for different operating temperature. Because in the operation condition, when the machine is off, that time temperature is not there. But when the machine is running, the temperature will be increased. So the viscosity, if the oil, it should be maintain the viscosity, even that the temperature is varying. It should not vary very randomly. Otherwise, what will happen? The fluid viscosity, if it is losing, then it will not act as a lubricant between those running surfaces. So the viscosity is the ability to flow in the pipe, or in case of we are seeing in the furnaces, in the burner, it should be that oil, furnace oil, for example, it should be fluid and it is suitable for automation. So here we are determining the kinematic viscosity of the oil. How we will calculate? Simply two things are there. For kinematic viscosity is denoted by mu. So it is a product of one factor. That is viscosity meter constant is there. That is capital C. Viscometer constant. That is apparate constant multiplied with the time in seconds. All that constant is available because that is the apparatus constant, and the only thing we have to find out the time of application. Time of application is what? Suppose you want to check the viscosity of the 2T oil. 2T oil will pour into this cup. Anyway, the procedure we will show while doing the practical, because at the different temperatures we will measure the viscosity, so easily you can understand. But here what we are doing, we are pouring the oil up to the mark, then we will keep a specific gravity bottle at the bottom and we will see how much time it is taking to fill up that 50cc bottle. That time we will take. At different temperature, because the heater setup is also there, at whatever temperature you want, you can measure at that temperature. You can measure the time of reflex of that fluid in that 50cc bottle. At different temperature we can do. So from this we can find out the kinematic viscosity of the fluid. Only kinematic viscosity, how it is a multiplication of one factor, that is viscometer apparatus factor multiplied by time in seconds. How much time, the time taken to fill that 50cc bottle. So coming to the flash point, here what we are doing, here also we are pouring the, suppose we want to find out the flash point of the diesel. We will pour the diesel into the cup. Here also the practical will be shown to you. So in cup is there, in the cup we will pour the oil. With the help of the heater setup, slowly we increase the temperature of the oil. At the particular temperature, what will happen? The fumes will form. When we bring the flame to that fumes, it will give a momentary flash. That temperature we are calling it a flash point. Means the oil giving fumes. In that fumes, if you are bringing the flame to that, it will give a fumetic flash. After that time, 5 to 10 degrees in temperature, if you rise in, what will happen? Then you will bring the flame to the vapor. That time also will form, more vapors will form, but that time it will not give flash. It will be a continuous fire. That is 5 point. That 5 point is not important. Flash point we are determined. That is the difference between the 5 point and flash point. So while doing the experiments, certain precautions we have to take. That main precaution is because this is the stirrer. Inside oil is there. So uniform the temperature, we are doing the stirring like this. During the stirring, this thermometer is also there. That is also inside. It should not touch us with the stirrer. Otherwise, thermometer will break. And we have during the experiment, we have to see that the temperature of the diesel or whatever the oil you are taking, that should not be heated more. That's why we have the control here. Temperature control is there. If it is heated, then fire may catch up. That precaution is also important. We should not fill more oil also, because in this apparatus also it is given indicator. It will give the mark. Up to that only we have to fill the oil. Here also some precautions in the viscometer also. Some precautions can be taken while stirring the bath. Here also, to uniform the temperature of the bath, we are doing the stirring. While stirring, we should take the care. And here also mark you can see, we should pour the oil up to the marker, not more oil we should not pour. Otherwise what will happen? There is a chances of mixing this oil and water. So anyway, detailed, while we are seeing the detailed experiment totally, then we'll get the idea, because at different temperatures we are going to do the viscometer test, and flash and 5 point. Once we are getting the temperature, suppose 75 degrees centigrade temperature, first flash came, then we have to repeat the experiment for again. Suppose 75 degrees centigrade is the flash point you got. So next time what you will do, again you will take out that oil, put it the fresh oil, again test from 70 degrees onward, 70, 71, 72, 73 to get the accuracy of that the flash point. So this flash point is also very important. This is the measure of fire risk. Suppose you want to store this oil or fuel storage, or you want to transport the oil into the tank. So fire point, this flash point is very important. If you know the flash point, then easily we know that we are safe in, safely we can transport the oil, or safely we can store the oil. That we can suppose our flash point came 75 degrees for the given oil. So more than 65 degrees centigrade temperature, if you are getting the flash point, then those are the safe oils. And while storing the oil, there, what are the precautions to be taken? There should not be any welding and grinding spots. While transporting the oil tank from one place to other place, there we have to ensure that oil tank should be full. Otherwise, what will happen? That vapors will be accumulated. So that may give rise to the catch up fire. In this view, we can see clear the parts of this redwood viscometer 1. In this view, here you can see cup is there. In this we are going to pour oil. At the center, orifice is there, small hole is there. This is the oil cup, and at the center, orifice or oil jet is there. See, orifice at the center. This is actually stirrer. And here coil is there. We'll pour water here. So in this view we can see all these things. One is heater coil, because we want to check the viscosity of the oil at different temperatures. For that we have to heat the oil also. To attain the temperature we need heater. For the heater, this is the coil. So we will pour the water also into the above this level, and slowly the water will be heated up. That heat will be transferred to this oil, which we are going to pour into this cup. So we'll keep one thermometer inside the cup also from this attachment. So here outside attachment is there. There also we'll keep one thermometer like this. Inside also we'll keep that one thermometer like this to see the inside the temperature of the oil, and outside also we have the provision to keep the thermometer. So finally we can see all these parts. One is the oil cup where we are going to pour the oil, and at the center orifice is there through which the oil go into the specific gravity bottle, which will keep bottom of this one, and stirrer we can see. The stirrer is to inform the temperature of the water, because through this only the temperature will be supplied to the oil. So see like this will determine the temperature of the water. So it is the apparatus redwood viscometer 1. We use this apparatus to determine the viscosity of the oil samples. In our practical, we are going to determine the viscosity of two type of oil. One is 2T oil and another is MAC L815W40, means that is petroleum oil. Closely we see the setup. In this setup, simply one cup is there. You can see this is the cup where we are going to pour the oil. This is the cup, oil cup. Here one small indicator is there. You can see indicator. Up to this level we are going to pour the oil. This is the cup, oil cup, and this is the marker. This will indicate up to which level we are going to pour the oil. Then at the center you can see one small orifice is there at the center, small orifice. This is the redwood viscometer 1. The dia of this orifice is small. If I want to check the viscosity, more viscous oils, then we use redwood viscometer 2. Only difference is the orifice dia is more than in redwood viscometer 1. Here orifice diameter is small and the length of the orifice is also small. That is the difference between redwood viscometer 1 and redwood viscometer 2. This is redwood viscometer 1. So at the center you can see the orifice. In the other direction, if you tilt this one, you can clearly see the orifice in this container also. So we will show in that mode also, we will show. Three things are over. This is the oil cup and this is the indicator, level indicator, up to which we have to pour, up to which level, what level we have to pour the oil. Up to this level we have to pour the oil. That is the orifice. And before doing the experiment, so this is the pin and ball arrangement. Here at the bottom ball is there. So orifice can be closed with this ball. After closing the orifice with this ball and pin arrangement, what we will do, we will pour the oil up to this mark. Before that, one arrangement we will see at checking the viscosity at different temperatures. We need a heater. So heater arrangement is here. You can see the coil here. This coil is immersed in water for heating for controlling the temperature. We need a regulator. Through this regulator we can control the temperature. So when the water is heated, through this heat, that oil also will be heated. To check the temperature of the oil, we place one thermometer inside the cup. So this thermometer will show the temperature of the oil. Here one more thermometer is there. This is the thermometer. It will measure the temperature of the water. Here you are seeing the water. So to maintain the uniform temperature in the water, what we'll do, we have the one stirrer arrangement here. This is the stirrer. Because at the bottom you can see some blades are there. So we can equalize the temperature, or you can maintain the uniform temperature of the water by stirring like this. Because this stirring will help to maintain the temperature. Because suppose our target is to measure the viscosity of the oil at 40 degrees temperature, then only with the stirring only it is possible. While stirring, what will happen? Slowly the temperature will be transferred to the oil. Once required temperature, when we get it, then we lift the bowl and we collect the temperature. At the room temperature, we want to determine the viscosity. It is not required. When we want to check the viscosity at different temperature, we'll start the heater and slowly the temperature of the oil will be heated. Once it is stabilized at the temperature, we'll lift the ball and we'll collect the oil into this bottle. This is specific gravity bottle, which is kept just below the orifice. So we'll measure the time, how much time taken to color this 50 cc bottle. That time will be noted down, but that time is very important to color the viscosity of the soil. That is called time of efflux. Now I am pouring the oil. So up to the mark, I poured oil. Before pouring oil, we have to ensure that the orifice is closed without ball arrangement. We have the stopwatch here. Simultaneously, we have to do this thing. When we lift this ball, we have to start the time also. Like this. We are seeing the time also here, and you can see here, that is oil is coming through orifice and it is collecting into this specific gravity bottle. So to measure the viscosity of the oil at a different temperature, suppose we target the temperature of 45 degrees temperature. If you see the temperature of water, it is 48. If you see the temperature of the oil, now it is only just 35. So to get the required temperature of the oil, what we'll do, we'll stir the water bath like this. Only by stirring only we can get the required temperature at which you want to check the viscosity of the oil. This is the only precaution we have to, while stirring we should take the precaution. Simply we have to do this one. Like this, when after stirring, once we get the temperature, required temperature, the same procedure, just we lift this bowl and we'll collect that 50 cc oil in the same gravity bottle. We'll note down the time, how much time taken to fill that 50 cc bottle, that we'll note down. From that we can determine the viscosity of the oil. Only room temperature means without heater, but at the different temperature means we'll use the heater. Once we'll get the required temperature, we will allow the oil to flow and we'll take the reading. So in this experiment, we are going to determine the viscosity of the given oil sample. We have two oil samples here. Matte 40, matte this one is 40. Two engine oils are there. So first we are going to determine viscosity of matte 40 oil with the help of this redwood viscometer 1. So here already we pour this 40 oil up to that mark, and presently we are not heating anything, we are checking at the room temperature. We are not given any supply to the heater. So at the room temperature only we are checking the viscosity of the 40 oil. Now sample is already poured, oil is already poured. Now our work is just whenever, as soon as the stopper is released, will start the time, the oil will be collected into the specific gravity bottle at the bottom. Now the temperature is 34 degrees centigrade. Now we already started the heater. Now the temperature is 40 degrees centigrade. The temperature of the oil is also 40 degrees centigrade. It is now equal to the temperature of the water. Now at this 40 degrees centigrade, we will check the viscosity of the 2T oil. Start. Stop. Now the temperature is 47. The temperature of the water is also 47. Now the temperature of oil is also 47. At this 47 degrees centigrade, we check the viscosity of this 2T oil. Start. Stop. Now the temperature is reaching 54 degrees centigrade. The temperature of the oil and the temperature of the water is also now equal. Now we are ready to determine the viscosity of this 2T oil. We are starting. Start. Stop. Here we are going to determine the viscosity of the given oil sample at different temperatures. So here given oil sample is petrol engine oil, MAG Elite 15W40. You can see the oil here. So we want to determine the viscosity of this oil. So here you can see the setup. Oil is already poured up to the mark and two thermometers are inserted. The temperature of the oil also we can see here, that is 34 degrees centigrade, and the temperature of the water bath also we can see here, 34 degree temperature. Means we have not provided any heat at the room temperature. We are determining the viscosity of the oil initially, that is at 34 degrees centigrade. The procedure is already shown to you in the previous video. Now we are directly do the experiment. We calculate the time of reflux of this 50 cc oil into this specific gravity bottle. Now we are going to start. Start. Now the oil is collecting into this specific gravity bottle. Now after heating, now the temperature is 40 degrees centigrade. Temperature of the oil is 40 degrees centigrade. Now at this temperature, we are checking the viscosity of this 40. Start. Now the temperature is 47 degrees centigrade. The temperature of the oil. At this 47 degrees temperature, now we are going to check the viscosity of this 40 oil. Start. Now the temperature of the oil is 54 degrees centigrade. At this 50 degrees centigrade, at 54 degrees centigrade, they are going to determine the viscosity of the oil. Max lead 50 W40. Start. You can see here temperature is more 54 degrees centigrade, that's why the flow is also increased. These are the observations of 2T oil and 40 oil. These are the temperatures we taken. 34, that is at room temperature, 40 degrees centigrade, 47 degrees centigrade, 54 degrees centigrade. So from room temperature to 54, slowly we raise the temperature. At different temperatures, we have taken the time of efflux of 50 cc oil in seconds, 221, 162, 148, 96. So if we are repeating the experiment at least 3 times, you will get the average value. That average value can be taken. So for finding out the kinematic viscosity, you can see kinematic viscosity in centistokes. We have to multiply two things. One is C, that is viscometer constant. The unit is Stokes, 0.00119, and the time is the time of efflux of 50 cc oil in second. So we have two things. We got that C, viscometric constant C, and we got the time of efflux at different temperatures. If you multiply these two, we will get the value of kinematic viscosity in centistokes. For getting that one, after multiplying, if you are multiplying, after multiplying these two, 221 into viscometric constant 0.0119, it should be multiplied with 100, then we'll get in centistokes. Kinematic viscosity centistokes. So 26.299, 19.278, 17.612, 11.424. Here we can observe with increasing the temperature that kinematic viscosity is gradually decreasing. Here also 40 oil we taken. 40 means that 15W40 car engine oil. This oil is also tested at different temperatures. What are the temperatures taken for 2T oil? The same temperatures we repeated for this oil also. Here also we can see the average timing, that is time of efflux of 50 cc oil, that is in seconds. So same viscometer we have used, that with viscometer 1, so constant is same. So we got the viscosity here also, kinematic viscosity in centistokes. Here also we can observe that with increasing temperature, that is 34 to 54 degree centigrade, the kinematic viscosity is also decreasing from 67 to 27. We can see through the graph also. Here this graph represents the effect of increase in temperature of 2T oil also, 15W40 oil also. Its effect on kinematic viscosity. When we are increasing the temperature, that kinematic viscosity is decreasing. This graph represents the 2T oil kinematic viscosity with increasing temperature. This graph represents the 15W40 car engine oil. This is also representing what it is indicating, that with increasing the temperature, the kinematic viscosity is decreasing. Highly viscous fuels, highly viscous oils like furnace oil. If we want to make it fluid for atomization, what we have to do? We have to preheat it. The second experiment to determine the flash point of the given oil. Here we are going to check the flash point of the diesel. Here diesel is there. To determine the flash point of this diesel, we need the apparatus. The name of that apparatus is ABEL flash point apparatus. This is ABEL flash point apparatus. It is a very simple thing. Only this is set up just heater. This is the heater, because we want to heat the oil here also. Diesel, if we want to heat, means we need a heater. Just simply it is a heater setup. Here you can see it is the brass cup. Generally we will clean this brass cup with the benzene or petrol. After that we will dry it. In this we are going to pour the sample, that is the diesel. Here also we can see the level indicator is there. See, up to this we will pour the diesel. When we place this cup into this heater, then heat will be supplied to this diesel. Slowly the diesel will be heated. You see the cup arrangement. Here you can see the stirrer, because to homogenize the temperature, to equalize the temperature of the diesel, we have to stir. Or the stirring arrangement is there. You can see the blades here. This is the stirrer from top. Can easily stir the oil the inside to homogenize the temperature of the diesel. This arrangement, see, window close, window open. This is the close arrangement, this is the open arrangement. This is window close, window open. This is for to measure the temperature of the diesel, because at what temperature it is giving flash, we have to measure. For that we need to record the temperature. That's why we will place the thermometer here. Care should be taken while placing the thermometer, because at the bottom you can see it may touch with the stirrer, so that you have to adjust like that. It should not touch with the stirrer movement. So in the cap we have three provisions. One is stirrer arrangement to homogenize the temperature of the diesel. Here to thermometer to measure the temperature of the diesel or given oil, and you have the window open and close arrangement. Here generally what is happening, we want to see the flash point of the given. Flash point means this diesel, when it is heated, it forms fumes. When sufficient fumes are formed, we will bring the flame over the surface of the oil just by opening. If sufficient vapors are formed, that is enough to create a flash. That is a flash point. Flash point means it is the minimum temperature at which the vapors formed will create a flash. And fire point, one more thing is there. That is the minimum temperature at which that fire will continuously come. Means more vapors will form, it will give a completely flame. That is the difference between flash and fire. In flash point, when the oil is heated, it forms vapors. In that vapors, when we bring the flame, it will give just a flash. It will not continuously burn, it will give a flash. That is the flash point. That temperature will record, that is called flash point. Fire point is different, that we are not going to calculate, but to know the difference between the fire point and flash point, the fire point is that where when we bring this flame to that vapors, that sufficient vapors, what will it will give continuous flame. That is the fire point. So here we are going to see the flash point of the diesel. Now diesel is poured into this brass cup up to the level indicator. Then we start the heater to increase the temperature of the diesel, and will be close the cup also. We will close the door. And we will fix the thermometer. We will wait for to temperature rise. Now the temperature is 70 degrees centigrade. We will check for the flash. No flash. Temperature is 75. No flash. The temperature is 80. Flash. So again we'll check. The temperature is 80 degrees centigrade. Flash came.